okay. You're not losing much, so don't worry. So hello and welcome everyone. And my name is Mali Tabataboi, and I'm part of the Wien International team. I'm a developer in that team. And before we start, I wanted to say a big thanks to the organizers who were not just active during this week, but also supported the speakers for the past few months with the content and presentation preparations and everything. For the great helpers there, thank you. And also for you who are attending the talk physically and in person, it makes such a big difference to the speakers as well. So thank you, everyone. And this talk requires some participation from the audience. So I hope you help me out here. And the first participation is a round of applause for yourself and for the organizers, please. So now that the energy level has come up, people woke up, Anwar there is now awake. So yes, I have a confession to make, and that's first of all, I do not have any funny slides, so no disappointment there. And the other thing is that I am not an expert in this domain. I have experience in designing and developing some solutions. I am a person who is interested, so have done some research, and I'm hoping that this talk will bring some energy to us all to start discussing, have more discussions in this domain. So I will start with a question to the audience, so participation is required, as I said, and how to eat an elephant. How to eat an elephant. Great. For those who English is not their first language, elephant is an animal with a big ear and a big nose. So how to eat an elephant? One bite at a time. And to me, this is a theme of this year's Tech Summit, and what a Tech Summit as well. In this talk, I will talk about cloud computing in general and serverless solutions in particular. And I'm going to start with some background to put us all in the same page, focus on some cloud computing models, serverless architecture, look at some kind of examples, and we'll wrap it up with a prediction for the near future in this domain. So cloud computing, why should we care? Why should we spend time in this session and in future to learn more about this topic? First of all, obviously, this is a theme of this year, so I'm giving the talk about it. We should care about it. But also, the research shows that, we have lots of success stories like Netflix and Coca-Cola who have benefited from spending years to move towards the serverless solution, cloud-native solutions. They invested hugely, and they are now sharing their success stories with the rest of us. So as a technology company, I believe we can also benefit from at least researching and investing more in this space as well. And there are so many different solutions at the moment in the market, but they are even improving these solutions and services, and they are creating more and more services for us to review and think if we can benefit from them for our products as well. So cloud computing. Some believe that this is a disruptive technology, but truly the concept of sharing time-sharing services is not a new concept. It has been there since 1960s, and even the terminology of the cloud is borrowed from the telecom industry, as it is the case for most of the network terminology. But what do we care from when we hear about the cloud is that the users do not care about the location of the services, the hardware, the operating system, because those are irrelevant to the users of these services. And for the past decade, we have seen more and more movement towards the cloud. But the Gartner Technology Institute, which is a research institute, actually tells us that there is going to be more investment from technology company like ours to move towards the cloud in the next few years as well. So for the people who, like us, are developers, product team, we need to understand better how we can benefit truly from this technology. And some of the benefits of the cloud is shout out in the literature when you hear about the stories. I won't bore you with all details. If we summarize the benefits of moving to the cloud, is that it makes our life easier, cheaper, and it makes our products greater. So if you want to remember only 3 things, you can just think about those. And who doesn't want all this? Hallelujah. So when we decide to move to the cloud, there are different deployment models. For example, the cloud models. This is a public cloud that, for example, we are using here as well. And most of the companies, they share the service, the servers and the services out there from the cloud provider like AWS or Azure. And there is the on-premise model, which is basically the servers are located with the company and they would install an instance of, for example, AWS. And that's for cases or scenarios like governments, like places that they need very high security data. You know, those are sort of scenarios that will be used for this model as well. And the hybrid model, which is a mixture of these two. So for those companies who want to gradually move to the, for example, cloud, or they have restrictions, for example, in sharing their data, they want to keep this locally, the services can move. There are, again, examples for those as well that use this model. But these models are decided usually somewhere at the beginning, high up people, and we follow, for the rest of the time with that model. So this is not a model that I want to focus on, but I want to focus on the cloud computing models. So I just wanted to compare these two. So when you hear about the models, there are different types of models that we're talking about. So cloud computing models are basically categorized in 3 main groups. Infrastructure as a service at the bottom of this pyramid, PaaS or platform as a service, and SaaS or software as a service. And is infrastructure as a service, as developers, as digital solution owners, we spend our resources about the setup of a virtual machine, and, keep them up to date and everything. So that's the infrastructure that we will set up. PaaS are more developer focused, so we will start only focusing on the application that we want to develop. We focus our resources only on that space. And software as a service or a SaaS, again, it will let the user only care about the products. I think most of us have been the user of the SaaS. If you use Google Documents, if you use Microsoft Web Word or Web PowerPoint, these are all examples of software as a service. So the infrastructure or the technology who these things have been developed is not relevant for the users. If you look at the cloud model from the responsibility point of view, you will see that from the left side, the darker boxes are the responsibility of the application owners, in this case, for example, Trainline. And the right side, the orange box are the ones that are responsible. The cloud provider is responsible for them, for example, AWS. So the more we move from the left to the right, we actually pass the responsibility to the cloud providers like AWS, and we give them our money and say, just give the service to us as well. So, and we focus only on our business model, on delivering our solutions. If you think where the serverless sits in this model, it is actually somewhere between PaaS and SaaS. So again, the aim is to remove more of the complexity of configurations of the services from the application developers and then pass them to the cloud providers. And some of the examples you will see on the left-hand side, like Azure function apps or, API gateways, both in Azure and, in AWS, Lambdas, function apps, all sorts of examples of serverless solutions that are already provided by the cloud providers. So I am sure most of you already have used or heard at least about some of the services that is provided by the cloud provider. Can I have some participations again? So the energy level goes up. What do you think is the most used AWS service? Just shout out your answers. S3, great. EC2, S3. I also have done the Spanish team. No, come on. Yes. DynamoDB, great. So yes, I have also done a bit of a research in this space, and they are not, by the way, the research done by the actual cloud providers as well, from the top 10 or top used services globally. And as you can see, EC2 is at the top of that list. Why? Even though it is an infrastructure as a service model, it is closer to our traditional way of thinking how to develop and deploy our solution. It's easier for us to do it. We feel we have more control. We feel that that's, the way that we can do it now, and then think about the problem of using the service. Obviously, this is my kind of justification. I will leave you also to think about it as well. But some of the other services that you can see here is all in the serverless domain. So it is important for us to look at these services that are provided to us and look at the serverless architecture, how we can put these building blocks together to actually create a large scale complex service as well. Sometimes putting these building blocks are a bit confusing. For example, in the domain of computation, we can think, okay, do I want a serverless solution or do I want a platform as a service solution? Which one is the one that I can, go ahead with? Which ones are even serverless and which one are PaaS? Because those are, all of them are targeted for the developers. So some people understand the difference between these models based on their cost model. If you do pay as you go, you are a serverless. If you pay for a period of time, you are, PaaS. So I want here just to focus from the requirement perspective, from the developer's perspective, to see if, for example, if you want to develop an API, would you put it in a Lambda or would you put it in something like, Elastic Beam? And in this case, you will see that if our solution needs to be event triggered, so something should trigger that solution to start working, it should be small, it should be single task, lightweight, and it should only leave for a short period of time and then, turn off. That's a kind of a sign to tell us, yes, this is a Lambda. But if it needs to run continuously, like an API that is available for our user to send requests when they have a request requirement, and the size can grow, or our requirements are not very clear. So we might even grow more and more, by adding features as well. And it doesn't need to be triggered to actually leave. That would be a sign to tell us, yes, this is a platform as a service. But why do we talk about serverless so much? First of all, I want to clarify the terminology of the serverless. It does not mean that there is no server. It just means that we do not care about the physical or the other aspects of that server. The server always exists. And what is this server? This server is a powerful computer that runs 24/7, and it gives us, some services via the network. So that's what we know as a server. And why do we want to move away from those servers, from that traditional way of designing and deploying our services? And that's because of some of the problems. Like the traditional way of using the servers, we spend these huge resources on purchasing these expensive machines, and we might have done like over provisioning. So most of the year, our resources are wasted. Or on the other side, we could have done under provisioning. So at the time of the sales, our services are going to be very slow and our users are going to complain, and we are not going to satisfy our users from that. And obviously then we are responsible for the maintenance, for the hardware and software, to keep security patches up to date, and all sorts of other headaches that we do not need truly. And when there is no server, there is no worry. And we only move from idea to the market faster. These are the promises of serverless. By no means I am advertising to use them blindly. I do not say let's use the cloud just for the sake of using them. But this talk has more focus on the benefits, and obviously there will be hopefully another talk on disadvantage, on the problems, on those red flags that we need to think about when we are designing these solutions. But again, I will remind you that what were the three main benefits? Make our life easier, cheaper, make our product greater. So these are the promises of the serverless for us as well. So we cannot find a solution that addresses all our problems. There is a challenge with any solution now. So it is better for us to know what are the problems of these type of services, so we don't use them incorrectly and then we say, oh, now I'm spending more budget on it. Oh, like my services are just, not working as I'm expecting. I am listing here some very basic ones that I have came across them, but again, there is a big space here to discuss what are the challenges when we actually look into design our solutions as well. The first one that is quite important is a budget. It's so difficult to actually calculate the budget on this serverless solution. Why? Because they are based on the usage. So when you have a pass, you will say, I'm going to pay for this period of time. You will pass that information to the managers and everybody, and they will calculate and estimate, the budget for the rest of the year. Now with the serverless, they provide us with some tools to help us do some calculations, more accurately, or like they bundle something to give us some better understanding of how much we are going to spend. And even nowadays, there are roles, there are people with this job title to help calculate the cost of our services in our serverless. So it is still challenging for us to estimate how much budget we need to allocate if we go fully serverless solution. Vendor locking, a big red flag. If we go serverless, we are going to lock ourselves to our vendor, being AWS, Azure, any cloud provider. And why do we care about that? I have a personal experience that in the past, my previous company, they did a very good negotiation. They got a very good contract with the Azure. They start developing our solutions happily for a few years. We have used, we provided some kind of B2B solutions to our clients. And then after a few years, when the time came to renew the contract, we did not get such a good, negotiation. We were not in a good space to do the negotiation. And that reached to the stage that we were, as a developer, we were asked to start looking at vendor-independent solutions, containerize everything, start even developing on AWS, because now they wanted to have a more powerful stage when they go for the negotiation. So it could be tricky for certain companies. And obviously, there are limitations to these services. So it could be, for example, computation limitations, query limitations, or even it could even slow down our services. So we need to know about these limitations and the limitations when we design our solutions. So there are so many different ways about designing your solution. These are, again, very opinionated ways that I'm just, presenting to you based on my experience. Obviously, first of all, is to read the literature, to know what services are available at this point of time, because they are always modifying and improving their solutions as well. And also look at the examples that are provided out there, look at the design patterns that we will see out there as well. And For example, I'm just putting a simple pattern of a serverless cron job. Cron jobs are the repetitive jobs, like some jobs that, will, for example, we run every night a job to clean up our logs, or we run, for example, a job to check the health of the system every hour. So these are like repetitive jobs that we have. They're called cron jobs. And there is a service on the AWS called CloudWatch, and this service is to monitor our services. That's like the main responsibility of that. But it also can trigger sort of an event for us as well on the period of time as well. So give like 10 minutes, trigger a Lambda. Now that I know about this pattern, I will think how I can put it into a bigger solution, combine it with different pieces of this logo and create a service. Again, this service is not a realistic service design or anything like that. It's just my example for the sake of the demo. So don't take it as a real example and the real service design. So when the users start purchasing their tickets on the travel day, there might be some delays, and they need to be aware of that delay, so they can arrange accordingly as well. That's a disruption notification. And what does it do? In this case, a cloud, what do you call it? Sorry, the CloudWatch would trigger, for example, every 5 minutes a Lambda. The Lambda should be triggered by something. It does not run by itself. So every 5 minutes, it will hit a Lambda, and the Lambda will go to my train provider and say, give me the information for my next hour. What are these train times, the journey information, etc. And it will add those journey details into a queue. When the information are added to the queue, they will trigger another Lambda, and that would review that information. Oh, there is a delay. What I'm going to do, I'm going to create a disruption message, and I'm going to put that into a S3 bucket. When a file is added to the S3 bucket, it will trigger another Lambda, and it will go and look at that information and apply some validation, say, yes, this is still a valid delay message, and I'm going to send it to the send a vortex message to the AWS Firehose. So you can see that there are several patterns has been used here. We have several microservices that are playing next to each other. And again, by no means, this is not a realistic, example. It just shows that we need to be aware of these services. So when they put them together, we can design a more concise solution as well. In the past, I have, as I said, designed and developed some solution. And I came up with some sort of a list of things that are important to me when I'm looking at my next, example. And then I thought I would share it with you here as well. And I'm hoping this motivates more of us to share your experience. If you see a problem and a red flag, bring it up for everybody, so the next person doesn't need to go through the same problem again. So there are so many different solutions, combinations out there. Try to review all these patterns. Try to review the combinations of these solutions, so we can understand and we can defend our solution, because we might have several parallel possible solutions in play. And if possible, create a walking skeleton for that solution. Walking skeleton are like a wireframe for the designers. We can use that to actually demo that this is a possible solution, and it will satisfy our main requirements. And obviously, we want to make our services as flexible as possible, but try stay realistic. That is a problem that I myself get stuck to so many times. I'm thinking so much about the future. That's like the core part of that business rule is like sometimes it's a bit lost here as well. And obviously, the deadline is important when we design our solutions. So the more we know about these services, we actually can deliver faster, because we spend less time to understand what is the limitation and what is the benefit of each of these services. And don't ignore the monolithic architecture just like that. still review if it is better to be developed in a monolithic way or microservices way. And obviously price matters. I cannot design the best of the solution that I like and take it to the manager and say, yes, this is very beautiful design. Let's have it. It will make my life easier. It would, make our CVs greater, etc. There is always a negotiation. Does it add value? And that sometimes is a price that doesn't make our services cheaper. So as I can see, some of you are falling asleep. So again, another participation from the audience. Who is this gentleman? Just shout out if you know. He is a wizard. He is a magician. Great. See, we have a geek in the room. Exactly. He is Dr. Werner. I cannot read, sorry, that far there. Dr. Werner Vogel. He is the CTO of Amazon. And as part of his job, he does predict the near future in the technology market. And obviously this year, as part of his prediction, he did a few predictions. And the first one, as we know it, AI will rule. So we need to know, we need to basically apply more AI in our services. The other one was that smart homes are going to have more practical usage in the healthcare industry, especially for the care industry. So one of the interesting predictions that he made, and it was quite interesting for myself, was that sustainability gets its own architecture. I put this slide for our sustainability team, exactly, sustainability rocks. So it's interesting because when we look at the sustainability, we usually think about recycling our boxes or, of don't waste food or don't travel in a certain way. I think this is a focus of sustainability as far as we say it. But how can we, as the product and developer teams, as architects, how can we apply sustainability to our services? Is it even possible? Again, remember, every time a server is running, there is a negative effect on the environment. They produce their own pollution. When we do this live streaming of video for the whole day, happily enjoying our, video, audios, etc., we are making those servers to run and run and run. So it is interesting that next time we are looking at a solution, we can think that, is this a sustainable solution? Does it let a server to run continuously? Or would it only run when it is required? I understand that we are running the virtual machines and not the whole physical machine. So there is also an argument to understand how these virtual machines running or not running or services running or not running actually has an effect. But his prediction that we are going to think about sustainability next time we are designing our solution was quite interesting. And I thought I better share. So if we circle back to the theme of this tech summit, great tech summit, yeah. Eat an elephant one bite at a time. We try to create our cloud native solutions, but we should focus more on these services that they provide, understand them better, design them better, so we can deliver a solution that actually satisfies those promises of the cloud. Cheaper, easier, better service. If we do not satisfy that, we have just used it for no reason. And think of these services like tools in a toolbox. There are so many tools out there. We need to know about these tools so we can pick the right one for our solution as well. And I hope that this discussion, this presentation, have brought up a little bit of a space for us again to discuss, to spend more time researching, investing in learning it in communities that, regardless of not using it or using it, try to discuss it between ourselves to see if these services will add value to our product. if we can have these cloud native products that support our users out there better using different cloud native solutions. Again, I wanted to thank you, everybody who joined me today. You all add great value by being here. So thank you very much for this opportunity. And thank you, the organizers.